Okay. So we learned about the average concatenate in some tokenized methods, tokenized functions in pig. Okay, those things you can use it. So about the mathematical functions. Mathematical functions are like you can see the absolute cube root. Okay, say you wanted to find the cube root of certain numerical values. Like this can be applied when you're doing statistical analysis, right? Those things you can use this kind of mathematical functions. Ceiling of floating point number, floor of a floating point number. Say for example, ceiling means if the value is okay, something else it is displaying. No? Can you see my correct screen? Ah, yeah. Okay. Ceiling is like if you have a 5.1 and if you do a fine, right? If you do a seal of this number, then it will give the highest value. But 5.1, it will give the value as of 6. Okay, the highest value of this point it will give. When we do a floor of that, then it will give the value as a 5 itself. This is how it works. And the logarithmic functions you can apply to your any numerical data, and log 10 also you can find out using log 10 operation, and you can do a round of it. If 5.1, then it will have the value as a 5. 5.7, then it will you can have get the value when you do a round of that particular value, then you can have it as a 7, something like that. Okay, then a square root also you can find it using the square root method of square root function. So these are the mathematical functions. Okay, the examples they have given, if you're going to find a numbers absolute number, okay, that it will give same like if you have something some text file or some data set, in that you have a numerical data, and that you can generate the for each of that you can generate the numerical data likewise. Similarly for a cube root, okay, we will see examples in this a ceiling, floor, logarithmic, okay, log 10, square root and all, and use a different function that I will take it later. First, I'll show some demo in this. I'll open my VTE lab, and last 2 times when we are trying to run the load the data into a MapReduce, that is in the MapReduce mode, that is into your HDFS, it was throwing error, right? There is some configuration that you have to do. Okay, what error it was throwing is it was keep on trying to connect to the a job history server, which is nothing but that the localhost it is trying to connect it. For that reason, we have to set the job history server and restart the map reduce daemon, then it will work. Okay, that I will show it how to do that, because you have to change your configuration file. Last class when I tried to load the data, because we were working locally, right? So if I tried to load the data into your HDFS, it didn't start it. It didn't. It loaded uh, not into HDFS. From HDFS to a pig environment, it didn't load it. It was throwing error when I do dump. So that I fixed it. It is because of some configuration file. Say what configuration you have to do is you go to user local Hadoop. Okay, in this we go to our configuration file cd mapred. No, in etc folder configurations files will be there. In that we have a mapred site.xml. In this file, you need to set this property. Okay, the property for the job history address you have to give. Here I'm giving it as a local host, and description is like comments. Okay, we are not giving description anytime. Screen is not visible. Okay. Okay, I have come to our configuration file directory. Okay, this is the directory, configuration file directory, and here I am going to map red site.xml. In that I have set this property. Okay, this property map reduce job history address. Okay, where it has to have the address for starting the pig, uh, that it is not knowing it while starting the pig. From a MapReduce mode, the job history is not getting stored. So that information that we have to present it. Okay, everyone has to put this configuration. Otherwise, you will not be able to load your data from HDFS to your pig environment. That it will not allow. Okay, after doing this, you may have to start the job server, job history server. That I will tell you what is the command for that. Okay, that command is okay. I can show that. Okay, you save this configuration. You put everyone put this configuration and save it. And after that, you should start the MapReduce server. MapRed hyphen daemon start. Okay, so before doing any change in your configuration file, you need to stop. Okay, stop all .sh. Make the change in your configuration file. Okay, then start all. It will start the job server also. Okay, if in case it is not starting, still you are facing some issue, then you can do this one, map red hyphen daemon. That particular daemon you can start it this way. But this option is wrong, I think. Some history server is there. Okay, that command I will give it later on. I missed it where it is present. Okay, this is the command. Okay, no need to do that one, this command, because it will already be running when you stop and start all the daemons. Don't format it and all. Name node format is not necessary. I told you why you have to do name node format in the beginning. Okay, so that you don't do it because you will lose your data. Daemon dot sh. Okay, start history server. This is the command. After, if you are particularly starting the map reduce mode, it is saying some error. I will put this in the group. Okay, what is this command? That I will put it. Okay, only if you do this change, then you can use your yeah, HDFS to load your data. So I will show you how do we load the data. For that I will go command see, we have changed the file in the mapred site.xml, right? Mapred site will have a job history service running, which keeps tracks of the jobs which are started in pig. Okay, that server, that daemon process, it is a process only, no? So that process we are restarting it to reflect this change, saying that to start this server also. That if that is not started, it keeps telling, it keeps looping in your, when you try to dump the relation data, that will keep looping and gives a error statements, because this server is not started, it is trying to connect to the server. That's why. Okay, then what I will do today is, we will do this one, we'll load our data into hdfs and do our mathematical operations, mathematical functions in that. Okay. So okay, I will. Sorry about that. I will come back. Okay, what I will do, I will put to my directory, which is pigdir, which is where I have some files. Okay, ls-lrt. This is the file. Say we will load your cust data into our HDFS. Okay, so I will launch pig in MapReduce mode, or I can give -x MapReduce, or I don't have to give anything at all. Okay, directly it will launch in a big MapReduce mode. Okay, this is the MapReduce. Okay, grunt shell has come. Now what I will do, I into a relation, I will load some uh, that cust data table was there, right? I'll post this. Here I will go. The file name is cust underscore data. This I will load it. Relation equal to load cust underscore data dot txt. So that file is going to be loaded from your hdfs, so from the root directory, using pig storage, comma separated file. Okay, I'm not giving any schema for that. Before that, I will also see whether cust data is put it in our hdfs. For that, I have to put hadoop fs hyphen put this uh, cust data into my root directory. Okay, so I will check it whether it is present now. Fs hyphen ls slash. So cust data, where it is loaded here into your hdfs. Now that I will take it in a pig environment relation. So load cust data using the pig storage, enter, and I will dump now rel. Okay, so it is throwing error, unable to open the iterated for alias backend error. Why? It is saying input path file does not exist. It is there, cust data. Okay, I will load something else, which is cdr.txt maybe. Okay, so what I will do, because this it is saying file is not present, I will load another file. cdr.txt, it is fine. Dump rel, still it is showing error. JPS is running, job history server is running. It is not able to find it. Okay, I will stop and start the services once. I'm actually checking it again because it is not loading. Uh, I'm just starting and stopping the processes. So this is the file in the HDFS. KJPS, it has started. Mm, there is this cdr.txt storage. Okay, enter. It is loaded. Dump, or I will give a relation name one. Dump rel1. Okay, some problem is there because it was working yesterday. Now it is saying that it is not loading. File is not existing. Okay, I will check this one. Okay, because it is saying input path does not exist. It is present in HDFS file. Okay, let's not spend time here. I will check it and I'll let you know. Okay, but it will work. Okay, one, but that configuration is needed. So if you see the JPS, there's a job server, history server is also running. So keep tracks of the jobs because dump will start your map reduce, right? When you are trying to dump it, it starts a job that will be kept a track by the job server, his job history server. And okay, okay, we will see our math eval functions, which is okay. For that, I will create a file, okay, like a vi maths.txt. In that, I will write some sample data like 1 minus 6.8, 3.3 minus 2.2, 200, something like that. Okay. So these are the contents I have in the max file. Beyond this, we will apply all our absolutes and other things, and we'll see. So first, this is in the pig directory. I'll go to the grand shell. From here, I will load that file into absolute. Some name I'm given relation. I'm going to find the absolute of that numbers. Okay, load the max.txt file that you have to give in quotes using pick storage. Okay, I have not, it is not a comma separated file. So pick storage and syntax should be same. It should start with P capital and S capital. Okay, it is not having any comma separated file if you see it in max.txt. So I'm not going to give any comma over here. I'm not going to say it is separated by comma. Directly you can give. Okay, as a so for the number I say it is having a floating point number. Okay, schema only one field is there and is of a type of float I'm giving. Okay, this is fine. It is loaded into ABS. Let's dump and check whether it is loaded or loaded properly. Okay, it is all fine. It is loaded in the form of a tuples. Okay, now we will find the absolute. For that, say for that the relation name I'm giving it as absolute for each of the ABS. Okay, that relation I'm going to generate the ABS. ABS should be capital because evaluation functions and the aggregation should be in capital letter. Okay, ABS num. I'm giving it. Okay, enter. For each ABS is the a relation name which is loaded with the max.txt, and for each of that relation we are going to find the absolute value. Absolute is going to take the field. Which field I'm going to take the absolute. Okay, that is fine. Then dump absolute. Okay, I'm in map reduce mode. That I will come out of this. Okay, we will launch it in quit eh, local grand shell. Okay, this is fine. Now again I will load it because I have come out of that shell, so it will not have it. ABS, then absolute. Now I will dump the absolute value. Absolute is going to have the absolute of the number. So absolute relation, if I dump that, you will get the result. Now see, it is not going to do anything at all. Whatever the values here, the negative values are removed, only the positive values it is giving. That's what absolute is doing on a mathematical function. Okay, say this kind of things where you can apply, say if you have a student, complete student data or some data set, or the employee complete data set where you are having the salaries in floating point numbers, and if they have given something in negative, it is possible, right? In your data set you will have a uh, error data, right? Wrong data, many data will be there. That time if you wanted to do an absolute of that, then you can use this absolute function. Okay, likewise. Now, what we will do, we will try to find the square root, cube root, square root, and all those things. So already I have loaded this. Once we loading of any of your data set into a relation is enough, it is already loaded in ABS. On ABS itself, you can find the cube root, square root. Okay, so now I will write a cube root. I will check equal to for each of the ABS data, generate the cube root CBRT capital you have to give, and for which field, a number field. Say for example, if age field is given, or if you wanted to find a cube root of any number, then that field you will pass it here. Okay, this is fine. It is only the warning. Okay, some implicit cast and all it is showing. It's okay, you can ignore. Dump CBRT. Okay, now it is giving the cube root of the numbers whatever we have given. Okay, if you see that number, these are the numbers. Cube root of this number it is giving, or else we will check the cube root in a different way. We will have some other file like a cbrt.txt. In that we will have a cube root for 9. uh, what else? 124, 29 will not come. Yeah, it is a square root. Yeah, 27. Tell me some more. No? 4, 164. 64 will come, yes. Some other like 120. 1000 we can give. Okay, likewise, you can have a cube root numbers. For that, it will find the cube root and it will give the answer. Okay, so CBRT is that one. I have to load the CBRT now, right? CBRT.txt file now, because I have loaded a absolute. Absolute is was having a floating point numbers. Okay, here I will load CBRT.txt file into CBRT. In that num, I will give it as an integer itself. No problem. Okay. Yeah, it will be like giving the answer in a floating point. If we give it in float, it will give it in dot zero like that. So I loaded it in CBRT. Now we will do for each on this. Okay, for each CBRT relation, we will find the CBRT value. Okay, that I'm storing into CBRT value relation. Okay, enter. Now dump CBRT underscore value. Okay, so it is giving in floating point only. Dot zero, dot 4.0 and 4.0. Okay, three values only we had it there. I have given for 100. It is not 1000. I have given 100. I have given. That's why. Okay. So it is giving in floating point only. Similarly, you can have the cube root also. Same thing cube root. If I sorry cube root we have found float values. Yes, the function is returning the values in float. Okay. So square root also you can say find for the same file. Okay, square root value. Simple only all this. You can yourself try square root underscore value. Okay, it is giving the square root value since for yeah 64 8 it has given. For 100 it has given 10. For 27 it is giving 5 point something. It is right. Okay, it is giving the floating point number values only. Okay, another function is like a seal, and seal is there that we will see. So what I have to write is for a C, I will also again open a file in that we will have some numbers for the seal. Vi seal dot txt. Okay, in that I will give like something like a 4.5 and 2.3 and minus a 5.5 minus a 6.7 1.0. Okay, this is the number I'm giving. Okay, see, these are the numbers it is having point numbers, all are floating numbers. Okay, this is point, not comma. Insert point 4.5, 2.3, minus 5.5, and 6.7, and 1.0. We'll see what the seal and the floor is doing. Okay, so in order to use the seal.txt, we have to load it. Load it in SCE. I'll load it. Load seal.txt file using pick storage. I'm not giving anything at all. No schema. Schema you can give as num. Okay. Otherwise, if I don't give schema, then how I have to do the next step. Okay, see, it is loaded into CE. You can dump and check also. Okay, I'm not dumping and showing because I thought you will understand, right? See, it is dumping in the form of tuples. Then now I have to find the seal for each of the CE relation. Okay, so seal underscore value is my relation name. In that, for each of the CE value, generate the seal function, a CEIL, and in that function we have to give the field name. Field name I have not given any schema, so field name I can give it as 0. The first field as $0. Okay, it will understand. Positional parameters. Okay, then afterwards dump the value. Dump controller dump. This is the one I have given, and the dump seal underscore value. Okay, see, now you can see it. 5 3, how it is giving 4.1, right? 4.1, 4.5, it is giving the value as a 4 5. 2.33 is giving it as a value. Okay, and for minus 5.0, 5.5, it is going to the lower level. This I you understand, no? Because negative means it goes to the negative. If it is going low means then it is higher, right, in negative. So for 5.5 minus 5.5, it is giving 5.0. 6.1, it is giving 6 minus 6.1. 1.0 is going to be 1.0 only because it is not having any other number. Okay, this is how seal works. And similarly the floor, how it works. FLOR, this is here same thing. I'm going to find the floor in for the same values. So I will give floor value equal to, then dump floor underscore value. See, floor is going to give the lowest values. 4.5, 4.0 it is giving. 2.0, 2.3, 2.0 it will give. Minus 5.5, it is going to give it as a 6. Okay, and minus 6.7, it is going to give it as 7, minus 7.0. So you must know where all you can apply to this. Whenever you are doing a mathematical statistical calculations, at that time you can apply all of this. Okay, operations. Okay, all of this functions. Is this clear? And round, we will know that it will round it and gives the value. I will show it. Log also we can check it in this. Same thing, we will check the log. From the same relation, I will check the log value. Okay, log. I load into a relation log value. Okay, dump under log underscore value. Okay, for negatives, it is not giving any value log. So NaN, not applicable, not present. For the positive values, it is giving the log value. One log is 0. Log 1 is 0, right? That's why it is giving like this. Clear? Are you able to follow it? And for the round, if I try to round the values, same thing, I will try with the round. OUND. Okay, dump round the value. So it will round, it will remove all the floating point numbers and it will round it and gives the value. Okay, so 2.3 is 2 it is giving, and above 5 and point 5 and above point 5 it is going to give the next higher values. 4.5 is giving us 5. Okay, then what else? Log 10 is there. That also we will see how it is going to give the value for. So all these things you should know that all these things are available in your pig scripts. This is a value, log 10 value. Okay, dump log 10 underscore value. Okay, it will also do a logarithmic 10 operation, and it will give us the result. Okay, guys, is this fine? Then after that, there is that I told, right, text loader. How do we load that? We will keep on loading it as a quick storage. As I told, there were four things. Where do fixed storage, storage input as a storage input. Then there were four things, right? Like fixed storage, um, bin storage. These are the four storage options. Okay, and text loader, and also there is one thing like a JSON loader. Okay, so likewise we can load our data. So I will show you how do we load it using the text loader now. Okay, so what I will do, I can have any text file. Okay, anything, say you can have already present text files here, like a text file itself is there, text file. Okay, I'll take this one. Okay, I will load this into the your pig environment, into your relation. How I will show you. Say it is a text. Okay, text equal to load. The text file name is a text file.txt, I think. Yeah, text file.txt. Okay, text file.txt using text loader. Okay. Okay, so directly I can load. You don't have to give it anything because it will load it completely as a text. It will not divide it as a tuple and all. Okay, text loader will completely load it as a text. Okay, you can also have other statements like I am attending Apache Pig programming classes. Okay, likewise, if I am writing, this complete thing will get loaded in the text file I have written. So if I enter this, now it will load the completed data set, the small data set into my text. In this, if you dump and check, dump text, you can see the complete thing is loaded into each tuple. Okay, likewise it will work. Say you can also give a schema for this. Okay, you are not saying in your text loader that whether it is a comma separated file or not. Only in pic storage you will say that control s. Sorry. Hmm, something had happened. Here you will not specify any of the comma separated files and all. Okay, using text loader, if I can give the schema also. The schema can be like for complete text. Okay, it's like text. I'll say it is a char array. Completely it will consider it as a char array. Okay, then enter it. Now if you see the describe of text relation, it will have the schema. It is having only char array. Okay, then I will dump and show how it is having the value. Relation is a text. So it has dumped the complete data set. Okay, this is how text loader works. And that is all. Okay, there is one more operator. The operator name is a flatten. Yes. That I have not checked. I will check it. I have noted it that, and that you have to specify particularly on a field type what it will be. That I will check it and tell you. And one more operator I will discuss now. The operator is a flatten operator. Flatten operator means if you are going to see, you can create your data, you can load your data set in the form of tuple, I told, right? You can also load it in the form of a bags means it will show it as a grouped data, right? If you try to group any data, it will give it in the bag format. Okay, so that one you can flatten it. Say for example, you loaded your data. I will show you uh, some group commands we will try. Okay, I will load that student relation. uh, Load studata.txt. This is the file. This I load it into my uh, using pic storage. It is a comma separate. You can load it as a text loader also, no problem. See, and also guys, this pic storage we are always saying that it is comma separated. Why? Because the file is comma separated and we are saying like that. It is also possible that file can be separated by dollar. It what do I mean here is the file here, yeah, here if, instead of a comma, it can be separated by dollar. Okay, or dollar or any other special characters. Okay, or hash. It can be like this also, hash and hash like this. In that case, then you have to give your uh, pic storage loading. While you are loading, you have to give the particular delimiter, that is called the delimiter, right? That delimiter, and you have to load it. Okay, that's what the difference. Now I give it as comma itself. Using we have done, and I will give the schema of name as I don't have to give the schema also because my intention is to show a different thing. So I will not give schema. Okay, and load it. It is loaded into student stud. In the relation, it is a loaded stud relation. So this is the data in my data set which is loaded into pig environment. Now what I will do, I will group it by the city. Since I have not given schema, if you see schema name for student, I have not given any schema. So I have to locate the fields using the positional uh, operators. Okay, positional numbers. Okay, so I am trying to group it by the city. Okay, city is in the fourth field. So if $0 is id, $1 is name, $2 is age, and $3 as city I will give it. Okay, so what I will do, I will have a relation group grp equal to group. What is the relation I'm going to group? Start by $3. $3 is city. Okay, positional characters. It is fine. It is only the warning. Now I will dump it. Dump a group. Okay. Now you can see that while grouping, it will create a bag and it will put the separate tuples into the bag. Okay. So I also showed you how you can load a data set as in the form of a bag. Bag like mm, yeah, see, sometimes if you wanted to flatten this, there is an operator like flatten. Flatten means Delhi, whatever you are getting it as a tuple, right? Delhi is with John. John is from Delhi, Suresh is from Delhi, and another Suresh with 35 age is also from Delhi. Okay, Ram is from Hyderabad, it is a duplicated value, and Tina is from Chennai. Okay, so if you are want to flatten, saying Delhi, Suresh belongs to Delhi. Again, I mean the bag. If you have loaded your data set in the form of a bag, and but you wanted to flatten it in form of a tuples, then that you can do it using the flatten operator. Okay, I'll show it with an example. Then it will be clear. What I will do, simple numbers I will take. Okay, vi flat.txt. I'll write it as a flat.txt file. In that I will have some numbers. Okay, some 0 5 2. Then I will describe it with the example also. 1 7 8. What happened? We flat.txt. In that 0 comma 5 comma 2, 1 comma 7 comma 8, 0 comma 1 comma 2, 2 comma 5 comma 2. Okay, so this is the numbers I will have it. Now what I will do, I will load this flatten file into my pig environment. For that I will write as flat, some relation name flat equal to load flat.txt using pig storage. Okay, it is a comma separated file. As I will give some field name like f1 as int, f2 as int, all are integer values. Field 3 is int. Okay, so if you can see it here, flat f1, f2, f3 all are integer. I am giving the field name something like f1, f2 and f3. Okay, so this I enter it, this gets loaded. Now we can check dump and check dump flat. Okay, all are this loaded into the tuples. Now what I will do, control L, I will group this one, group this based on some field. Okay, group group equal to relation name, I'm giving it as a group, and the group flat by flat is the relation which is loaded by, say, f2. F2 is the field name. Okay, grouping it by field f2. Okay, field 1, field 2, field 3 I have given, I'm grouping it by field f2. Okay, so now it will throw error. Why? Because it will throw error. Why? Because the relation name and the operator name should not be same. Okay, that's the reason it is throwing error. So I will give the relation name as a different. Okay, group and group operator name is also same. No, that's why it is throwing error. I gave a different name. Now it has grouped. It is not a. It is only a warning. Okay, before you can see it is an error. Okay, if I check the dumped grouped values, okay, dump group 1, see how it is grouping. 5 has 2 entries. Okay, if you can see in the table, I will increase the font. Where do I increase the font? No need to increase the font, right? It is fine. No, it's visible, right? Okay, here it is not showing option for me. Okay, 052. I am grouping it by field 2. Okay, if not field 1, field 2. Field 2, 5 has 2 entries. Okay, that it is grouped together and giving it as one result. Okay, put it in a bag and giving it as a result. 1 is having a one result and the 7 is having one result. Okay, that's how it is grouped. Say for example, you think that your data set is looking like this. Now you wanted to see the tuple values. Okay, not like a flattened, not like a grouped value. Okay, I will write it in the this one. What the flatten will do is, say for example, I have a data set like an employee data set. Okay, employee data set, if you remember it, then he has an ID, name, and also have an address. Okay, ID you can give it as a E001. Okay, and a name I'm giving it as a Peter, and address I'm giving it as a number 47 Chennai, and something. Mm, what else? Something is it? Number 47 Chennai, and you have a ED002 and John. Okay, and his number is like same. Both are from the same place, 47 Chennai. Okay, then I have another employee EDEE003, and if I say his name, her name is Mary, and number 55 Mumbai, like that. Okay, and another employee, four employees if we are having, like Jyoti something, somebody, and number 54 Delhi, like that you are having it. Okay, so if you load this data set in the form of a group, say for example, this is a loaded in the form of group having Chennai containing two entries. Okay, Peter entry and John entry. and Mumbai having one entry, which is a Mary, and Jyoti. I mean, Delhi is having one entry, which is Jyoti. Okay, Jothy. Jyoti. So, what flatten will do, if I try to flatten this grouped data, it will give the result in this way: Chennai, Peter, Chennai, John. The tuple values it will give. Okay, Chennai, comma, Peter, it will give. Okay, whatever we are trying to display it, along with that, Chennai, John. Okay, what flatten operator will do is it will reduce the level one level lower than uh, the current data model. This is the data model we say. Bag is a data model we say. Map is a data model we say. Tuple is a data model we say. Tuple is the lower level data model than bag, because bag is a group of tuples, right? So when you do a flatten on the bag, it will give one level lower than its level. It means it will give one level lower than bag. It is nothing but a tuple it will give. Okay, that's what the flatten will do. Flatten, you understand, when it's giving the flat values, what it will do, it will give reduce to one level than bag, and it gives the result. So it will be like Chennai Peter, Chennai John. If Mumbai is having multiple entries like 2 3 4, then it will be like Mary comma Mumbai, and again it will have 2 comma Mumbai, 3 comma Mumbai. Likewise, it will give the result. That is what the flatten will do. Then why you can use the flatten, where you can use the flatten is, sometimes your data set you are storing it in the form of a bags, but you wanted to convert into a tuple, bag to a tuple, and then work on that values. In that cases, you can go for this a flatten operator. Okay, so what I will do here is I will do one thing. I'll show it how it is working using the flatten operator. Okay, since we have done this one, okay, how do I flatten this? And now I have to flatten this values, right? How do I do that? We know the dump group one is containing all these things. I told flatten will reduce one level. This is the bag level. One level lower than this is convert everything into a tuple and it will show. Okay, for that one, I will write flatten. Okay, flatten value val equal to for each group 1 generate flatten. So which based on which field we are going to flatten, on the relation dot f2, because we have grouped it based on the f2 value only, right? This is the relation. From this you hope understand it. Flat is a relation where I loaded all the data. Flat dot f2 means I'm going to take flat this relation and this field. Okay, that's what I'm going to do here. It will be not there. I will again write it flatten underscore val equal to for each group 1 generate. For each will do for every record. Okay, generate spelling, generate a group, not group, flatten only we can give flatten uh, flat dot f2, that field. Enter it. It is a fine, it has a flattened it. uh, Now we can check it. So I will display the results, a dump flatten underscore val. But it is giving 1557. Something is wrong, I think, in this. It is actually doing it for its value only. It is not giving proper result. I will check it once again. Okay, I don't have to give the field name here. Flatten the relation, then dump flatten underscore val. Yeah, now it is giving the proper value. What I've done is I tried to flatten it based on a field. So it is not giving result. I'll just describe the result, then I will tell. So dump flat value, what it has done. Okay, so 1 comma 0 1 2 it has done. See, if you see the result, I will delete this. What are the values? 0 1 2 2 5 2 0 5 2. It is like this அவ்வளவுதான். 1 comma பசங்க 0 1 2, that's all, it will be over now. This is what the group, right? Group was like this. Okay, 5, it had two entries, 2 comma 5 comma 2. Sorry, I will finish it now, don't worry. Comma 0 comma 5 comma 2. Okay, then afterwards it was having 7, again one entry with the okay, 7 comma 1 comma 7 comma 8. Okay, this is the grouped data. Okay, just listen this, that's all, I will finish this. Okay, this is the group data. How it flattened 1 comma 0 comma 1 comma 2, 5 comma 2 comma 5 comma 2, 5 comma 0 comma 5 comma 2. Can you see that? That is how it has flattened. 7 comma 1 comma 7 comma 8. This is what it will do. Okay, if you have a city over here, if it is a Chennai, then Chennai comma like a Peter or Chennai comma John, likewise it will flatten it. If in the before query I have given the field name right here, flatten dot f1. Okay, that's why what it has done, it was giving the result like this. Where is that? It was taking the field name 1 only f1. So 1 comma 0 it gave, 5 comma 2 it gave, 5 comma 0 it gave, 7 comma 1 it gave. Like this also you can flatten it. This is the flatten operator. Okay, this will be also useful. In the case of address, I will discuss one logarithmic or a student file. Okay, in the after finishing this, that time I will also tell you how this flattens and all, and map also I will tell you how you can write it. Okay, using that. Okay, that is all for now. You can leave if you don't have any doubts. Otherwise, in the afternoon, we will see the remaining sessions of Pig scripts. Okay. Any doubts, Maria, Prakash, and Amalan, you can ask me. Otherwise, we can stop it here.